In this video, we're going to look at the examples on pages 17 to 21 of the 3-2 slides. We're starting off with this question. IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. What percentage of IQ scores are between 70 and 130? Well, if we come back over here and look at the empirical rule, it says that 95% of all values fall within 2 standard deviations of the mean. If we look at these values, we've got 100 as our mean and 15 as our standard deviation. So 70 is 2 standard deviations less than the mean, and 130 is 2 standard deviations greater than the mean. This means that about 95% of IQ scores are going to fall between 70 and 130. Moving on, we've got this question about Chebychev's theorem. IQ scores have a mean of 100 and standard deviation of 15. What can we conclude about Chebychev's theorem? From Chebychev's theorem. So here we look at Chebychev's theorem, and it says that at least 3/4 or 75% of all values lie within 2 standard deviations of the mean. That means, for our purposes here, at least 75% of all IQ scores lie within 2 standard deviations of 100, so that's between 70 and 130. Additionally, we've got this, at least 8/9 or 89% of all values lie within 3 standard deviations of the mean. Well, within 3 standard deviations of 100 with a standard deviation of 15, that would be between 55 and 145. So we're saying that 89% of all IQ scores are between 55 and 145. For our last problem, we come over here to this example. For the Verizon data speeds in the textbook, the mean X bar is 17.60 megabytes per second, and the standard deviation S equals 16.02 megabytes per second. And I'm just writing that information down. That's the 17.60. And for the earthquake magnitudes in the textbook, we have the mean is 2.572 and the standard deviation is 0.651. And we're asked to compare the variation of the 2 data sets. So to do that, we're going to come over here where I've written down the data, and we need to calculate the constant of variation for each of these, the coefficient of variation for each of these data sets. So the coefficient of variation is just S divided by X bar times 100. Okay, so that's going to be 16.02. Divided by 17.60 times 100, or about 91.023. For our earthquakes, our CV is 0.651 over 2.572 times 100, or approximately 25.311. If we come back here and look at this, and And it says to round the coefficient of variation to 1 decimal place, so that's going to be 91.0 and 25.31. So this tells us that our standard deviation is much smaller compared to the mean when it comes to our earthquakes as opposed to our data speeds, which means that that our earthquake data is more spread out. It has greater variation overall, lesser variation overall, and our data speeds have much greater variation. That's it for this video. If you have any questions, please do get in touch.